Most riders think buying an electric bike with a massive battery means unlimited range. But what if I told you that most e-bikes on the market are lying about their distance claims by up to 50%? Bikes advertised with 100-mile ranges that die after 40, marketing hype that sounds incredible in the store, but leaves you stranded halfway through your commitment. In this video, we're counting down the 13 electric bikes with actual honest range claims, ranked from number 13 to number 1 based on verified testing and real-world performance. And here's the twist. The top bike exceeds its manufacturer's claims. Stick around because this isn't just another list. It's the only buying guide that'll keep you from wasting thousands on range promises that never deliver. Number 13. 10Ways EgoX. Starting at number 13, we have the 10Ways EgoX. This urban all-rounder takes a different approach to range honesty. Instead of throwing big numbers at you, 10Ways focuses on efficiency through component selection. The bike uses a 250-watt Bafang mid-drive motor paired with a Gates carbon belt drive system. This combination isn't just about looking premium, it's about delivering sustained real-world performance that actually matches what riders experience day after day. Now, why does this matter for range? Belt drives eliminate the friction losses you get from traditional chains. Less friction means less wasted battery power, fighting against mechanical resistance. Every pedal stroke converts more efficiently into forward motion rather than heat and wear. While specific tested range numbers aren't widely published for this model, the engineering tells the story. When you select components that minimize energy loss, you don't need massive batteries to achieve respectable distances. Mid-drive motors work with your bike's gears, keeping the motor operating in its sweet spot. This means consistent power delivery without the battery-draining surges you get from cheaper systems. The component choices here prioritize sustained efficiency over flashy peak specifications, which translates to predictable real-world performance you can actually count on. The EgoX proves that honest range comes from intelligent design, not just throwing more battery cells at the problem. Number 12. Ride 1UP Portola. At number 12, the Ride 1UP Portola brings realistic expectations to the folding bike category. Folding bikes face a unique challenge. Smaller wheels mean less efficient rolling, which typically hammers battery life. The physics are unavoidable. Smaller diameter wheels complete more rotations to cover the same distance, and each rotation involves friction losses. Ride 1UP claims 30 to 50 miles of range on the 500 watt-hour battery option, and these numbers reflect the reality of compact wheel design. Notice something? They're not promising you the moon. That 30-mile minimum estimate accounts for real riding conditions: hills, headwinds, heavier riders, and higher assist levels. The 750-watt hub motor delivers adequate power without the absurd consumption rates of overpowered systems. This conservative approach means you won't be shocked when your actual range falls short of expectations. You'll plan your 25-mile commute confidently, knowing the bike will deliver. For a folding bike, these numbers represent honesty in a segment filled with inflated claims. The portability comes with a range trade-off, and Ride 1UP doesn't hide that fact. This transparency separates realistic products from marketing fantasies that leave riders stranded. When a manufacturer acknowledges the limitations of their design category, it signals engineering integrity over sales pressure. The Portola won't win range competitions, but it will get you where you need to go without surprises. Number 11. Rad Power Bikes Radster Road. Coming in at number 11 is the Radster Road from Rad Power Bikes. This model signals a shift in the mass-market e-bike world toward prioritizing components that actually matter for daily use. Rad Power equipped this bike with two critical features that directly impact range reliability: a torque sensor and full UL certification of the electrical system. These aren't glamorous marketing points, but they're the foundation of predictable performance. Torque sensors measure how hard you're pedaling and match motor assistance proportionally. This prevents the wasteful power dumps you get from basic cadence sensors that just blast full power whenever they detect pedal movement. Think of it like cruise control versus constantly flooring the accelerator. One approach conserves energy intelligently, the other burns through it recklessly. UL certification means the battery, motor controller, and charging system passed rigorous safety testing, including stability through 1,000 charge cycles. That certification process weeds out poor quality cells and inadequate thermal management. A battery that maintains its health over time is a battery that maintains its promised range. This isn't about peak performance. It's about sustained, predictable performance over years of ownership. When budget brands start prioritizing these features, it signals the entire industry is moving toward accountability. Rad Power built their reputation on accessible pricing, and the Radster Road shows they're maintaining that value proposition while elevating quality standards. Number 10, Lectric One. Number 10 brings us the Lectric One, and this bike makes a bold engineering statement. Lectric paired a 750-watt motor with a 6-speed pinion gearbox and Gates carbon belt drive. You're probably wondering why gearbox and belt drive matter for range claims. After all, both systems cost significantly more than traditional drivetrains. So what's the actual benefit beyond the premium price tag? Traditional drivetrains with exposed chains and derailleurs create friction, especially when they're dirty or worn. More friction means the motor works harder to maintain speed, which drains the battery faster. A chain that's slightly rusty or inadequately lubricated might only rob you of 5% efficiency initially, but over a long ride that compounds into serious range reduction. The pinion gearbox is sealed and requires minimal maintenance. The belt drive doesn't stretch, doesn't need lubrication, and maintains consistent low friction for the bike's entire lifespan. This setup ensures that the bike's efficiency on day 1 is nearly identical to its efficiency on day 1,000. Range claims only stay realistic if the components maintain their performance, and this drivetrain configuration does exactly that. It's an investment in long-term reliability rather than short-term marketing hype. Most riders don't think about component degradation when evaluating range claims, but it's the difference between a bike that delivers promised performance for years versus one that disappoints after 6 months of regular use. Number 9, Aventon Level 3. At number 9, the Aventon Level 3 focuses on refined efficiency through intelligent power management. This commuter uses a 750-watt hub motor, but the key differentiator is the torque sensor integration. Hub motors are generally less efficient than mid-drive systems because they can't leverage your bike's gearing. They're stuck spinning at whatever RPM the wheel demands, which often pushes them outside their optimal efficiency range. But a torque sensor partially compensates for this limitation by preventing unnecessary power usage. When you're cruising on flat ground with minimal effort, the motor provides minimal assistance. When you hit a hill and pedal harder, the motor responds proportionally. This intelligent power management makes every watt-hour count. The difference between proportional assistance and full-blast power delivery might seem subtle during a short test ride, but over 40 miles it determines whether you arrive home comfortably or push the bike the last 3 miles. This responsive modulation keeps power consumption aligned with actual need, rather than dumping full assist constantly. Aventon also integrated advanced features like geofencing and remote motor deactivation, demonstrating a design philosophy focused on real-world usability rather than just marketing specifications. The Level 3 represents the modern hub drive approach. Acknowledge the efficiency limitations, then engineer around them with sophisticated sensors and software. When done correctly, the result challenges mid-drive efficiency while maintaining the simplicity and lower maintenance of hub systems. Number 8, Lectric Express 750. Number 8 is the Lectric Express 750, and this bike breaks conventional thinking about budget e-bikes. Priced under $1,000, this model includes features typically reserved for premium bikes: full-size wheelbase for stability, hydraulic disc brakes for reliable stopping power, and critically, a torque sensor. The inclusion of this sensor at this price point represents a significant market shift that benefits consumers across the board. Budget e-bikes usually skip torque sensors to cut costs, relying on simple cadence sensors instead. This cost-cutting destroys real-world range because cadence sensors waste battery power with their crude on-off power delivery. The Express 750 claims 45 miles of range on the 500 watt-hour battery, and the torque sensor makes this claim believable. Without that sensor, you'd expect maybe 30 miles from a battery this size with a 750-watt motor. The sensor bridges that efficiency gap. By matching power delivery to rider effort, the bike avoids the efficiency penalty that plagues most entry-level hub motor systems. This is range realism through component selection, proving that honest performance doesn't require premium pricing. Lectric demonstrates that accessible pricing and accurate claims can coexist. The race to the bottom on pricing drove many brands to sacrifice critical components. But the Express 750 shows that competitive pressure can also drive inclusion of features that genuinely improve the riding experience. Before we continue with number 7, understanding why most e-bike range claims fail requires looking at the testing methods manufacturers use. Manufacturers often test under laboratory conditions that don't exist in real life. Constant moderate speed on perfectly flat pavement. No wind. A 165-pound rider. Lowest assist setting only. These conditions create a fantasy world that bears no resemblance to actual commuting or recreational riding. These perfect conditions create theoretical maximum ranges that real riders never achieve. Hills drain batteries fast because fighting gravity requires massive power. Climbing a steep grade might consume 10 times the energy of flat riding. Wind resistance increases exponentially with speed. Going from 28 to 35 miles per hour doesn't just use a little more power, it uses dramatically more. The physics of aerodynamic drag work against you at every increment of speed increase, creating a squared relationship between velocity and energy consumption. Stop-and-go city traffic kills range because you're constantly accelerating from zero, which demands peak power output. Think about how much harder it is to get a heavy bike moving from a dead stop versus maintaining 15 miles per hour. That initial acceleration burns battery capacity at an alarming rate. The bikes on this list either test in realistic conditions or state their claims so conservatively that real-world performance matches or exceeds expectations. This is the critical difference between marketing fiction and engineering reality. If you're serious about finding an e-bike that actually delivers on its promises, make sure you subscribe and hit that notification bell. We're cutting through marketing nonsense to bring you real data on bikes, gear, and riding strategies that actually work in the real world. Too many channels just regurgitate manufacturer specs without questioning the claims or testing the products. And that approach leaves viewers wasting money on disappointing purchases. Number 7. Gazelle Ultimate C380 HMB. At number 7, we have the Gazelle Ultimate C380 HMB, a city bike that demonstrates how premium components create predictable range through mechanical efficiency. This model uses a Bosch Performance Line motor with 85 Newton-meters of torque paired with either a 482 or 625 watt-hour battery. For the 500 watt-hour version, Gazelle claims 25 to 55 miles of range. This wide spread accounts for the dramatic difference between lowest and highest assist levels. Notice the wide bracket. This reflects different assist levels and riding conditions, which is honest marketing. Many brands would just advertise the 55-mile maximum and ignore the 25-mile minimum, leaving riders shocked when they use higher assist and run out of power. But the real range secret is the drivetrain, an Enviolo 380C VT hub and Gates carbon belt. Continuously variable transmission means no distinct gear changes, which eliminates the energy losses that happen every time you shift a traditional derailleur. Each shift in a standard drivetrain involves a momentary power interruption and chain tension change that wastes energy. The motor stays in its efficiency zone constantly. Combined with the belt drive's low friction, this setup ensures that the battery's potential translates directly into distance without mechanical losses eating away at capacity. The range claims stay accurate because the components support efficiency over thousands of miles. This is what premium pricing should deliver: sustained performance that justifies the initial investment. The Gazelle costs significantly more than budget alternatives, but the component selection ensures that its efficiency advantage persists for the bike's entire usable life. Number 6. Super 73R Series. Coming in at number 6 is the Super 73R series. This moped-style bike pairs a 750-watt nominal motor with a massive 960 watt-hour battery. Super 73 claims 40 to 55 miles of range, and here's why this matters. They specifically state 40-plus miles under throttle-only operation. This single specification demonstrates more honesty than most competitors show in their entire marketing materials. Throttle-only is the worst-case scenario for range because the motor does all the work with zero pedal assistance from the rider. Most manufacturers hide this number or avoid testing it entirely because it reveals the bike's true efficiency floor. By providing a realistic throttle-only figure, Super 73 gives riders a predictable minimum range, regardless of how they use the bike. This level of transparency is rare in the industry. You can plan around a guaranteed 40-mile range and treat anything beyond that as bonus distance. If you pedal at all, you'll exceed the 40-mile baseline. This transparent testing approach eliminates the surprise factor that ruins so many e-bike purchases. You know exactly what you're getting under the worst conditions, which makes planning rides reliable. Super 73 built their reputation on honesty and distinctive styling that doesn't compromise function, and this range methodology reinforces that commitment. The moped aesthetic attracts buyers who want the look, but the realistic range claims keep those buyers satisfied long after the initial excitement fades. Number 5. Aventon Adventure Point 3. At number 5, the Aventon Adventure Point 3 represents reliable all-terrain performance with honest range expectations that account for the inherent limitations of fat tire design. This fat tire electric bike consistently appears in top recommendations because it balances capability with realistic claims. Fat tires create a range penalty. The increased rolling resistance and weight demand more power to maintain speed. This isn't a defect, it's physics. Many fat tire bikes compensate with enormous batteries but still make unrealistic claims by testing on pavement at moderate speeds. The Adventure Point 3 takes a different approach by setting expectations appropriate for the bike's design. It doesn't promise sports car performance from a truck platform. The engineers understand physics and price the bike accordingly. If you want to ride sand, snow, and rough trails, you accept the range trade-off that comes with 4-inch wide tires. The market position of this bike confirms that riders value predictability over inflated numbers. When your range claims match actual performance ride after ride, customer satisfaction stays high, and the bike earns its reputation through consistent delivery rather than marketing hype. Aventon's conservative approach builds trust that flashy competitors can't match. The brand could easily claim higher numbers by testing in ideal conditions, but that short-term marketing gain would create long-term customer disappointment. The Adventure Point 3 sells well precisely because it underpromises and overdelivers. Number 4. Mach-Wheel Basalt ST 2.0. Number 4 brings us the Mach-Wheel Basalt ST 2.0, a bike that illustrates why bigger isn't always better when it comes to battery capacity and range claims. This model packs a 940 watt-hour battery, one of the largest in the Class 3 category. The 750-watt rear hub motor hits 1,100 watts at peak output. Mach-Wheel claims 60 to 80 miles, and independent testing showed 37 miles in high assist and 63 miles in low assist. These results tell an important story about efficiency versus capacity. Here's the lesson. Despite having a massive battery, this bike doesn't achieve the range of smaller, lighter mid-drive bikes with 625 watt-hour batteries. Why? Physics. The Basalt uses 26 by 4.0-inch fat tires and full suspension. Those components add weight. The tested weight hits 82 pounds without cargo or accessories. They also increase rolling resistance significantly compared to slimmer commuter tires. Every advantage in traction and comfort comes with an energy cost. Every rotation of those big tires fights against friction that lighter bikes don't face. The motor works harder to move the mass, draining the battery faster despite the huge capacity. The range claims are realistic because Mach-Wheel accounts for this resistance penalty, but it demonstrates that battery size alone doesn't determine actual distance. Efficiency matters more than capacity, and component selection determines efficiency. The Basalt is honest about what it delivers, but it proves that throwing more battery at an inefficient design produces diminishing returns. Number 3, Velotric Discover 2. At number 3, the Velotric Discover 2 shows what modern hub drive bikes can achieve with proper engineering and component selection that prioritizes efficiency over raw power. This commuter uses a 750-watt geared hub motor with 75 Newton-meters of torque and a 706 watt-hour battery. Velotric claims 75 miles or more. Independent testing delivered 40.9 miles in high assist and 85.6 miles in low assist. Read that again. The tested maximum exceeded the claim maximum. That maximum range exceeds the claim, which is almost unheard of in this industry, where overpromising and underdelivering has become standard practice. The performance comes from one critical component: the torque sensor. Hub motors are inherently less efficient than mid-drives because they can't leverage gearing, but the torque sensor closes much of that gap by preventing wasteful power delivery. This intelligent system reads rider input dozens of times per second and responds precisely. Instead of dumping full assist constantly like crude cadence sensor systems, the Discover 2 provides smooth proportional assistance matched to rider effort. The entire electrical system carries UL 2849 certification, confirming that the battery maintains its capacity and safety through extensive charge cycles. Real-world testing shows this bike significantly outperforms the average for its class, proving that hub drive bikes can deliver realistic and even conservative range claims when engineered properly. The Velotric approach demonstrates that hub motors aren't inherently inferior. They just require more sophisticated control systems to match mid-drive efficiency. Number 2, Ride 1UP Prodigy V2LX. Number 2 is the Ride 1UP Prodigy V2LX, and this bike flips the range game entirely by deliberately understating capability instead of exaggerating it. It uses a German-made Bros TF Sprinter mid-drive motor with 90 Newton-meters of torque. Ride 1UP estimates 30 to 50 miles of range. Independent testing achieved 31 miles in the highest boost mode, confirming the minimum claim even under demanding conditions. But here's where it gets interesting. The same test achieved 65 miles in tour mode, a moderate assist setting that most commuters use for daily riding. That's 15 miles beyond the manufacturer's maximum claim. Think about what this means from a business perspective. Most companies exaggerate range to make sales, gambling that disappointed customers won't return bikes or leave negative reviews. Ride 1UP understated their bike's capability, and real-world testing proved the bike outperforms its own marketing. This happens when engineers prioritize system optimization over flashy specifications designed to win comparison shopping. The Bros motor is exceptionally efficient, operating within its ideal RPM range through the bike's gearing across varied terrain. Combined with sophisticated power management that smoothly modulates assistance, the system converts battery capacity into distance with minimal losses. This is what honest range claims look like: conservative estimates that riders actually exceed in normal use. The Prodigy V2LX builds customer loyalty through positive surprises rather than managing disappointment from inflated promises. And now the number 1 electric bike with the most realistic range claims. Number 1, Trek Allant Plus 8S. At number 1, we have the Trek Allant Plus 8S, the gold standard for range reliability that combines premium components with engineering excellence. This premium commuter uses the Bosch Performance Speed motor, delivering 85 Newton-meters of torque, paired with a substantial 625 watt-hour Bosch Power Tube battery. Trek claims up to 90 miles maximum range. Real-world testing shows riders achieving approximately 75 miles in eco mode before hitting the low-power cutoff. That's exceptional distance, but the real story is consistency. That's massive distance. But here's what really matters beyond the raw numbers: the predictability. This system requires only about 8.3 watt-hours per mile in eco mode. For context, a conservative industry estimate for calculating minimum range is 20 watt-hours per mile. This bike operates at less than half that rate. That efficiency gap represents engineering excellence that cheaper competitors simply cannot match regardless of battery size. It's the difference between good components and genuinely optimized systems. The Bosch mid-drive system represents peak efficiency engineering. It leverages your bike's gears to keep the motor operating in its optimal power band constantly. No wasted energy from operating at the wrong RPM, where the motor struggles inefficiently. No power dumps from crude sensors that blast full assist regardless of actual need. Just smooth, proportional assistance that matches terrain and rider effort seamlessly. The 625 watt-hour battery isn't the largest on this list, yet the bike achieves some of the longest ranges. This proves the fundamental truth about realistic e-bike range. Efficiency beats capacity every time. You can strap a massive battery to an inefficient bike and still get worse range than a properly engineered system with moderate capacity. Now that you know which e-bikes deliver honest range, you need to see the flip side. Check out our video, 17 electric bikes that fake their range, to discover which brands are lying to you and why their claims will leave you stranded mid-ride.